Hello. Purpose of today's video is to talk about basically absolute value graphs, and what we're going to do is try to make a connection between the equations that we're given and the graphs that are produced. So first thing is, we know that the absolute value graph looks like the line y equals x. The line y equals x usually is going to look like a diagonal line, and it's going to go off in both directions. That's the line y equals x. The absolute value function takes all of these negative y values and makes them positive, so they describe distance from zero. So if we take away the one half of the ray, we get both halves. These form the absolute value. Now, what we can do is, before we take the absolute value, if I took all of my inputs and subtracted 3/2, then this would be the same absolute value graph, it's just further away from its home. And to figure out how to walk at home and all that other stuff, we could just remember here that x minus 3/2, if x were a positive 3/2, we would have 0 right here. So in other words, when I look at this equation, here's what I see. I see an absolute value graph that is shifted to the right 1.5. The slope of each of those lines or rays is going to be 1 or -1, and the shift is to the right 1.5. So, in the end, I went really fast there. In the end, you have two rays. So your job is going to be, once you actually take a V-graph, now again, how did I make this graph? First of all, I took my vertex at the origin and I moved it over 1 1/2. So now my vertex is 1 1/2, 0. And the next thing that I do is I make a line, a ray, whose slope is 1. So I go over 1, up 1, or over 1.5, up 1.5. In either way, I have a slope of 1 in this direction and a slope of -1 in this direction. So that's, I can also tell where my y-intercept is going to be. And now I can actually look at this and say, well, the y-intercept of this line will be -1.5, and the slope is 1. So this ray is going to have -1.5 for the y-intercept and a slope of 1 for the slope. This one's going to have a positive 1.5 y-intercept and a slope of -1, so y equals 1 1/2 minus x here. So if you look at carefully, what I've done here is I came up with this ray by looking at the fact that the slope is 1, and I knew that from the original equation, and I know that the y-intercept is going to be negative, so I chose the opposite, or so I chose the negative here. This one, I looked at the y-intercept and the slope, and that's how I got this here. Now, you know you did this right if you follow the definition of absolute value. The absolute value says, if everything in here is already positive, absolute value says, do nothing, leave it alone. The absolute value also says, if everything in here is already negative, absolute value says, take the opposite. The opposite of x minus 3/2 is the negative x plus 3/2. So from my equation, I can see there's two rays, and from my graph, I can see there are two exactly of the same ray. So without as much talking, here I see slopes of 1 or -1, and this time, I'm actually, after I take the absolute value, I'm subtracting 3/2. So I'm going to take everything that happened in the absolute value and move it down this time instead of to the right. So I go here. And here, again, what I was able to do is know that the vertex is now moved down 1.5, and since the slope is 1, this is going to be 1.5, and this is going to be -1.5. Putting all the pieces together, this is a slope of 1, y-intercept of -1.5, so I get that equation. And then the slope here is -1, and the y-intercept is the same, -3/2. Boom. So once again, I did my work correctly. That is, my graph is right, the shifting down and everything, if I can take this, by definition, if absolute value, if what's inside the absolute value is positive, absolute value says leave it alone. So if you just leave it alone without absolute values, you get x minus 3/2, which is this guy right here. The other thing about absolute value says if x is already negative, then we take the opposite. So there's the opposite of x, and the same y-intercept, minus 3/2. All right, so here again, this time it's the same problem, only this time I'm going over, well, I need to make this move, the absolute value graph has to move to the left 1.5. And the reason I know that is because if x is -3/2 plus 3/2 equals 0. So you can always check yourself by putting in a number to make the absolute value 0, and that's going to describe to the left or to the right you need to go. So the slopes are going to be plus or minus 1, and we're going to shift to the left 1.5. Once again, because the slopes are 1, I know the y-intercept here and the y-intercept there are going to be 1.5 or negative 1/2. So looking at the ray, the one with the negative 1 slope and the negative y-intercept, and this ray has a positive 1 slope and a positive 1.5 y-intercept. And the absolute value says if it's already positive, leave it alone. Or if here is negative, we need to take the opposite of it. Opposite of everything inside, the opposite of x and the opposite of 3/2. Boom. These match. Here again, slopes are plus or minus 1. And we are going to shift the graph up 1.5 because that's what this says. After you take the absolute value, increase all values by 1 1/2. So the absolute value looks like this. I want all the values to be increased to 1.5. So that's what I got. So I know the y-intercept is 1.5 for both, and the slope is going to be positive 1 and negative 1. Yeah. And leave it alone. Take the opposite of the absolute value. It's an agreement. I hope you're catching the pattern here. This takes the absolute value graph, shifts it up 6. So I'll just go slopes of 1 or negative 1, and we shift up 6. And y equals x plus 6, y equals negative x plus 6. Slopes are plus and minus 1, and the y-intercepts are the same. And once again, I am actually going to say, look, with the equation, without even looking at the graph, I'm going to get 2 rays. One of them is where I leave it alone, and the other one is where I take the opposite of what's inside the absolute value. Last but not least, this says left 6 because when x is negative 6, we get a 0 here. So here you're saying negative 6, 0 is a solution to my equation. Negative 6, 0 is the vertex of my graph. Again, line with a positive slope and a positive 6 y-intercept, and a line with a negative slope, and then I extend the line over and infer that it's going to be a negative 6 y-intercept. So I got that. And then my equation, to get rid of the absolute value, 1, leave everything alone. 2, take the opposite of everything inside. Boom. So again, I went through that really as quickly as I possibly could. I hope you find that helpful. But again, the big idea here is you can tell what the equation of each ray is just from looking at your transformed graph. You can also tell what each ray is by getting rid of the absolute value, leaving it alone, getting rid of the absolute value, taking the opposite. Hope this was helpful. Have a good day.